Hello girls and boys, welcome to Blackboard Techniques. This is CBSE Class 10 Math Series. In this class, we'll be solving example 5th problem. If you check out the playlist, you'll be able to find out the previous introduction video for this problem. If you understand that concept only, you can solve this problem easily. So, do check that video first. After understanding that, you can watch this video. Now we can see the question. Here the question is, prove that square root of 3 is irrational. Prove that square root of 3 is irrational. You have to know what is irrational, what is rational. Everything I have explained in my previous video. Do check that video first. Now we can see the solution. In this problem, we'll be solving several steps. So you have to remember that steps, then only you can finish this problem. For the solution, we are going to follow several steps. Step number 1 is assume the opposite. Here, what is opposite? Actually, we need to prove that root of 3 is irrational, right? So we are going to assume the opposite means root of 3 is rational. We are just assuming that square root of 3 is rational. Okay, so assume the opposite means square root of 3 is rational. Okay, in general, we can write the rational number in the form of fractions, right? Already we had discussed about this. We can write the rational numbers in the form of fraction. So I'm going to, you can take any letters. I'm going to take A by B. Fraction means one numerator divided by denominator, right? So you can take any letters. I am taking A and B. And here, for any rational numbers, if you are writing in the form of fraction, that denominator should not be 0, right? For example, I am taking 2 by 3, the fraction rational number, for example, 2 by 3. This 3 is not equal to 0, right? And 2 and 3 are integers, right? Integers, and also the 2 and 3 are co-prime also. Co-prime means what? Co-prime means if two numbers has the common factor is only one. Common factor, I mean, two numbers have no common factor except 1. Okay, for if you are considering 2, what would be the factors of 2? 1 and 2, right? And for 3, what would be the factors? 1 and 3. So here common factor is 1, right? So this 2 and 3 is co-prime. We can say 2 and 3 is co-prime. Whatever number has only one common factor, that is 1, number 1. Such type of numbers are called as co-prime. Just we are considering 2 and 3 here. So we can say 2 and 3 are co-prime. These are all the conditions. When some number is rational, these are all the conditions can be applied. So same conditions we are going to apply here. So we can write where A and B belongs to integers, right? You have to write all this. A and B belongs to integers and B not equal to 0 and A comma B are co-prime. Co-prime. You can take any rational number, like you can take 2 by 10. We can simplify 1 by 1 2 is 2, 5 2s are 10s. Here 1 by 5, right? This 1 and 5 also co-prime. Why? Because this has one factor of 1 is 1 Factor of 5 is 1 and 5. So the common factor is 1. If two numbers has common factors only 1, we can say that numbers are co-prime. So we can say 1 and 5. So whatever rational number you are taking, that particular two numbers, if it is in the fraction form, we can say that two numbers are co-prime. This is common thing. Okay, we are applying all thing over here. That's what I have written over there. This is step number 1. Okay, step number 1 is assume the opposite. For every this kind of problems, you have to follow these steps, right? If you want to prove any number as irrational, you have to apply the first step as assume the opposite. Opposite means we have to write the given number as a rational. Accordingly, we need to apply these things, right? This is step number 1. And you can take this as equation number 1. Okay, we are going to follow several steps based on this equation. And step number 2. Step number 2 is we are going to simplify this term. For that, we need to remove this root first. Then only we'll be able to simplify this full term. Okay. Next, step number 2. You remember this line. Step number 2 is here we are going to simplify this term. So we should remove this root first. So remove the root. Step number 2 is remove the root. Okay. Here, if you want to remove the root, we have to take the square values, right? If you are taking the square value root 3 the whole square equal, if you are taking the square value on left side, you should take right side also. So a by b the whole square. Root 3 square means root 3 into root 3. So here a square by b square, right? Root 3 into root 3 means answer is 3, right? So we can write 3 equal a square by b square. We can cross multiply this 3 and b. 3 into b square. 3 into b square equal a square. This is the step. This is the equation number 2. Second equation we have gotten from step number 2. Okay. From first step we have gotten this equation, and next step we have gotten this. This is step number 2. Okay. And next, step number 3. Number 3 is apply the theorem. What theorem? Already we had learned about this, the important theorem. Let me write this. Step number 3 is apply the theorem. Theorem is if P be a prime factor of any integer a, then P divides a square, also P divides a. Already we had explained about this theorem with the example. P is a prime factor. A is any integer. Okay, let me explain the same thing again. I am taking a equal 12. Okay, and I am finding the prime factors. 2. 6 2s are 12. Again 2. 3 2s are 6. 3. So the factors of 12 is 2 into 3. Okay, here we need to take the prime factor, any one of prime factor. So I am taking here 3 here. Okay, so here P is 3. P is 3, A is 12. Divides A square means 12 square. A square means here A square is 12 square, right? How much? 144. This here the statement is P divides A square. We can divide this 144 by 3 completely. You can check it out. We can do that. And you can divide this 12 by 3 completely. So here P divides 144, that is A square. P divides A. P divides A square and P divides A also. That's the thing, right? From this statement, we know this. Now, that is the second step, right? From the second step only we are applying. In this second step only we are going to apply the theorem. So, again we can write the equation. I am taking the same thing. Here, P divides A square. Also, P divides A. Here, we can take the prime factor as 3. Okay. This P divides A square and also this P divides A, right? P means 3. We are just applying the theorem in this formula. So, 3 divides A square and also 3 divides A. We are applying the formula here. Okay. So, we can write in another way. Like A square is divisible by 3. Divisible by 3 and A is divisible by 3. A is divisible by 3. Okay. In this formula, we are applying the theorem. So, from this, we know that 3 divides A square, also 3 divides A. Okay. In another way, we can write it as A square is divisible by 3 and A is divisible by 3. Here, the thing is A is divisible by 3. We want that equation. This, we can take this as equation number 3. Right? A is divisible by 3 and this is step number 3. From step number 3 we have gotten these statements, right? Don't forget this. And step number 4. What would be the step number 4? Step number 4 is substitute A equal 3C. A equal 3C means here we have the prime factor is 3, right? So, in this case, A is divisible by 3, right? So, I can write A divided by 3. Already I have taken A is 12, right? A is 12. For example, A is 12 and A divisible by 3 means 12 by 3. So, A divided by 3 equal 4, right? 1 3 is 3, 4 3s are 12. Here I have gotten A divided by 3 equal 4. So, I can write 3 into 4, right? So, if I am taking this 4 as C means I am getting A is equal to 3C. C represents any integer. We can write, we are representing any number as any integer as a C. this is common term I'm taking. This is the example for understanding purpose. I'm writing over here, but here the general term is A equal 3Z. Why 3Z? Because in this case we are having the prime as 3, right? So in case of A, that means in this equation we are going to apply the equation, this A value, the value of A in this equation. Apply. We can take this equation, this is as equation number 4, right? 4. So 4. So apply 4 in 2. This is second equation. 4 in 2. In that equation we are going to apply the value of A. So what should be the next step? 3b square equal A square. A square is 3z, right? 3c the whole square, right? General term we are applying, okay? And 3b square equal 3 into 3. 3 square means 9, right? 3 into 3, 9. 9c square. So here we have 3, here we have 9. So we can divide 1 3 is 3. 3 3s are 9. In this way we can simplify it, right? So b square equal 3c square, right? B square equal 3c square. We can take this as equation number 5. Okay, in this case we have gotten this equation, right? So in this equation we are going to apply the same theorem what we have done before. Like this kind of equation only we have gotten this, right? We have gotten, right? This and this both are same kind of equation. So we can say, if you are applying that theorem, we can say b square is divisible by 3. Same like b square is divisible by 3 and b is divisible by 3, right? From fifth equation, after this, from 5, b square is divisible by 3. B square is from 5. Apply the theorem, okay? Apply the theorem again. What should be the next step? B square is divisible by 3. And b is divisible by 3. Right? B square is divisible by 3, b is divisible by 3. This is equation number 6. What is third equation? A is divisible by 3, right? That is third equation, 3 and 4. Equation number 3 is a square is divisible by 3 and equation number 3 is a is divisible by 3 and equation number 6 is b is divisible by 3. This is step number 4. Step number 5. From 3 we know that a is divisible by 3. From 6 we know that b is divisible by 3, right? So here a and b has common factor of 3, right? So we know that a and b has common factor of 3. Common factor of 3. So a and b is not a co-prime, right? Why? Because so a and b is not a co-prime. Why? Because it has common factor 3. if it has common factors only number 1, we can say it is a coprime, but we have the common factors 3. So A and B is not a coprime. So our assumption is wrong, right? Initially in the step number 1, we assume that square root of 3 is rational, right? Rational means A and B are coprime. We assumed that way. But we proved that A and B is not a coprime. So our assumption is wrong, right? So our assumption is wrong. Assumption is wrong. So that we can say square root of 3 is irrational. If it is rational means A and B will be coprime. Okay, here we have gotten A and B are coprime, so that not a coprime. A and B are not a coprime. So that square root of 3 is irrational. This is the technique is called as proof by contradiction technique. Already in my previous introduction class, I have explained about proof by contradiction technique. If you do not, just check that video first, then only you'll be able to understand this concept. So that square root of 3 is irrational. So finally we proved that. We had followed 5 steps. Every steps you should remember it, then only you will be able to finish this problem. You have to remember all the steps. Step 1 is what would be the first step, what would be the second step, what would be the third step. Everything you have to know. For that you have to know what is the important theorem which is used in this technique, what is the proof by contradiction techniques. You have to know every concepts, then only you'll be able to do this problem. In exercise 1.2, first problem is square root of 5 is, prove that square root of 5 is irrational. You can follow the same thing. You can follow the same steps. You'll be able to find out the solution. You can do it yourself. The question is square root of 5. Here square root of 3. You can follow the same steps, but the thing is the prime would be 5. Here we are using 3, 3, 3, and in that problem we have to use 5. That's the difference between this and that. But all the steps should be the same. You can follow the same thing. The answer, you can find out the answer. This much I had in this video. I hope this video helpful. If you found this video helpful, hit like button, share it with your friends, and subscribe to the channel Blackboard Techniques for more updates. We'll see you in another video. Until then, Shiny signing off.